Hi there, my name is Claudio Semini and I'm the head of the Dynamic Legged Systems Lab. Today I'm excited to talk for the first time about the first field tests of a legged robot in a vineyard. Now my lab has over 14 years of experience in the design and the control planning of dynamic legged systems, mainly hydraulic quadruped robots, as you can see here in the timeline. Today I will talk about HiQ-Reel, our 140 kilo power autonomous version. Quadruped robots can be applied to different tasks, mainly in disaster response, precision agriculture, space, inspection, surveillance, but in also many other fields. Today, I will exclusively talk about precision agriculture. Now, in particular, I will talk about Project VINUM, which is a collaboration project between the IIT in Genoa and the Università Cattolica del Sacro Cuore in Piacenza. At IIT, we have two teams collaborating. It's the April team of the ADVR department and the Dynamic Legged Systems Lab, which is my team. On the Università Cattolica side, we have the teams of Matteo Gatti and Stefano Poni. And we're tackling the problem of winter pruning of grapevines with through automation with AI and robotics. Now, the winter pruning is an annual operation that has to be done mainly manually in the vineyard. And you can see here on the right side, this is a table of all the operations that the people have to do inside the vineyard in each year. And we can see here marked in green that the most labor-intensive operations are harvesting and winter pruning. And so we're tackling the automation of winter pruning, because even if pre-pruned by a machine, here the machines can just cut at the same length, there's always a finishing by hand necessary. This is important because depending on the cut, this will then influence on the optimal quality and quantity of the grapevines, of the grapes growing in the next season. Unfortunately, there's an increasing shortage of skilled labor. People that want and can do these works are getting less and less. So if we put automation into the vineyard and into agriculture in general, we can increase sustainability. So the VINUM system concept here has at the core a manipulator arm with a cutting tool and an RGBD camera. Onboard computation and everything is mounted onto a mobile base. Now here illustrated is a legged robot, but in the first few years of the project, we've used a wheeled base robot. And we can see here a few impressions of 2019 and then earlier this year, where the robot is working in a lab environment, first at IIT and then also at Unicattolica on the right side and here in the bottom. And here you can see how the robot is performing first cutting and approaching with the cutting tool. In the bottom, you can see a recently broadcasted news in which we give a first glimpse into the project. The VINUM pruning pipeline looks like this. First, the mobile robot, in this case the legged robot, walks through the row of the vineyard and approaches a plant. Then it brings the arm out to then do a scanning of the entire plant and detect the spurs. The spurs is where we want to go and have a look closer, and we move with the arm to the spur and then take a close-up shot of this spur to then do a plant organ segmentation, pruning points identification, and then the extraction of the 3D point to then approach with the cutting tool and perform the cut. If you're interested in this part of the project, then please have a look at these recently published papers and data set. I will now focus mainly on the navigation experiments with the quadruped robot in a vineyard. As you can see here in the picture, we brought this our HiQ-Reel quadruped robot to the Tenuta Pernice vineyard. This is in Borgonovo Valtidone, close to Piacenza, and together with our collaborators Unicattolica, we did some first trials in the vineyard. Here are a few videos where we can see on the left side the 140 kilo heavy HiQ-Reel robot is navigating here with a crawl gate on tilled soil, and on the right side you see the same experiment on grassed soil. And you can see here on the left that the legs are sinking in deeper in the tilled soil with respect to the more stiffer ground on the right side where there's grass. To make it a bit more challenging, we found rocks and compacted soil, and we put them in front of the robot so that we can demonstrate also the rough terrain locomotion capabilities of our robot. You can see here that it adjusts successfully to the new environment. Even if rocks are not so stable, it keeps the balance and manages to overcome these obstacles. If you're interested in knowing more about the project, please visit vinum-robot.eu or follow us on our socials. Thanks to everyone, to the team and the team leaders